Welcome back to the IGCSE Computer Science Code 0478 guide. This chapter we will be discussing about algorithms, which is part of exam paper 2. Most students, including myself, think that this chapter is one of the most difficult ones. However, just pay close attention and try to attempt the exercise questions and you'll do fine. In this chapter, you will learn about assigning values using the arrow operator, pseudocode for conditional statements, pseudocode for loop structures, pseudocode for standard actions, writing pseudocode for a given algorithm, and error checking pseudocodes. In pseudocode, we assign a variable using the arrow operator. The variable on the left of the arrow symbol is assigned the value of the expression on the right. The arrow operator is also equivalent to the equal sign. In pseudocode, the following mathematical operators are used. Also take note that logic operators such as AND, NOT, and OR are also used in pseudocode. Some examples of pseudocode assignments. Gender is equal to M, which means that the gender has the value M or male. Price is equal to 100 multiplied by 3, which means that price has a value 300. Discounted price is equal to price times 10%. So the discounted price is 300 times 0.9, which is 270. We will be discussing about two conditional statements. First, if then, else, and if. It is used when a condition can be either true or false. For example, if marks is greater or equal to 50, then print pass, else print fail, and if. Second, case of, otherwise, and case. It is used when there is a choice between several different values. For example, case grade of A, print excellent, B, print good, C, print average. Otherwise, print needs further development, end case. The two conditional statements can also be drawn as a flowchart in the following way. Loop structures. Some actions in an algorithm require repetition. This is known as iteration. Loop structures are used to perform the iteration. Let's first discuss about the for to next loop structure, which is also known as the for loop. This is used when a variable is set up with a start and an end value. The variable is incremented by 1 until the end value is reached and the iteration is complete. The for loop must have the structure shown below. Repeat until. It is used when the number of iterations is not known and the actions are repeated until a given condition becomes true. The actions in the loop are always completed at least once. The repeat until loop must have the following structure. While do and while, or while loop. It is used when the number of iterations is not known and the actions are repeated while a given condition is true. The loop will repeat forever while a set condition is true. The while loop must have the following structure. Standard actions in pseudocode. Input statements. It is used for data entry and is usually followed by a variable where the data input is stored. For example, input name. Output statements. It can also be written as print. It is used to display information from an algorithm. For example, output sum or print sum. They both basically mean the same thing. Totaling. It is used with repetition to keep the total value every time the loop is repeated. For example, the receipt total is equal to receipt total plus cost of item. Counting. It is used with repetition to keep a count of the number of times an action is performed. For example, count is equal to count plus 1. Counting can also be used to count down, with the counter being decreased by 1 every time the loop is repeated. For example, count is equal to count minus 1. Producing algorithms with pseudocode. Write an algorithm to input 1000 numbers. Count how many numbers are positive and how many numbers are zero. Output the results. Use either pseudocode or a flowchart. To do this, use your knowledge from the information previously discussed. I will give 2 example questions for you to solve yourself at the end of the video. To solve this, I like to start by noting down the important key terms. To create this algorithm, we need to declare the variables, input the numbers, repeat 1000 times, count the number of positive numbers and number of zeros, and then output the results. The 2 variables we need to find are the number of positive numbers and the number of zeros. So, count 0 is equal to 0 and count positive is equal to 0. The numbers 10 and 20 show the line of code, and it is not necessarily needed to be written. For this algorithm, I will be using a for loop since the number of repetitions are already set to 1000. So, for count is equal to 1 to 1000, and inside the loop, we input the number. If number is 0, then count 0 is equal to count 0 plus 1. This line is basically used to count the number of zeros. Else, if number is greater than 0, then count positive is equal to count positive plus 1. This line counts the number of positive numbers. Next count. Since we want to repeat the program for the next number, we use next. We also put the next count outside the loop. And finally, print count 0 and print count positive. This is used to output the number of zeros and positive numbers. We put this outside the loop, otherwise the program will keep on outputting the count every time it is iterated. Your final program might not look like this, though you can refer to the mark scheme on the right to see how you can get marks for this question. In my case, I fully accomplished all the parts where marks are provided, so this program right here would get me full marks. Next example question. Write an algorithm using either pseudocode or flowchart to input a positive number, use this value to set up how many numbers are to be input these numbers, and calculate the total and average of the numbers. So what do we need to do? Input the positive number to determine the values, initialize the total, repeat x times using the input value, calculate average, and output average and total. First, input positive num count. Here, we input the positive number to determine how many numbers are to be input. Total is equal to 0. Here we are declaring the variable total. For count is equal to 1. 2, positive num count. Since the total number of repetitions are already known, we can use a for loop. Input number, and remember to place this inside the loop. Total is equal to total plus number. This is to count the total value. Next count. This will be placed outside the loop. Average is equal to total divided by positive num count. To find the average, we divide the total number by the number we entered at the start. And lastly, print total and average. On the right, we can see the mark scheme for this question. Here we can see that my program is actually quite similar to the one provided. Exercise question 1. Write pseudocode that performs the following. Ask a user to enter a number. If the number is between 0 and 10, write the word blue. If the number is between 10 and 20, write the word red. If the number is between 20 and 30, write the word green. If it is any other number, write that it is not a correct color option. Hint, use the AND logic operator. Your answer should be similar to this one right here. The AND logic operator is used since each color is specified within a range of numbers. Exercise 2. Write pseudocode that will count all the even numbers up to a user-defined stopping point. Your answer should be similar to this program right here. Here, num is the number that the user inputs, so that the program can count the even numbers up to the user's input number. The even numbers are printed inside the loop since we want to output all even numbers up till the user's input number. Error checking pseudocode. Sometimes we are given a pseudocode which contains some errors. We then have to spot the errors and find a suitable solution. This is known as debugging. The most common errors you can find in the exam include: variables are initialized with an inappropriate number, for example, totals equal to 1 instead of totals equal to 0. Assignment of variables are backwards, for example, 1 is equal to x instead of x is equal to 1. These two are actually completely different. Statements are not indented inside the loop. Statements are placed inside the loop when it is not supposed to. Incorrect usage of the greater than and less than operators. While or repeat until loop has no exit clause, for example, and while is missing, and the final output is written within the loop, causing excessive output. Try to remember these common errors as it will extremely help you in spotting errors. Example 1. An algorithm has been written in pseudocode to input 100 numbers and print out the sum. A repeat until loop has been used. Count is equal to 0. Sum is equal to 0. And repeat, input number, sum is equal to sum plus number, count is equal to count plus 1, until count is greater than 100 and print sum. In this question, there's actually only one error. So let's see. Alright, this statement right here. This algorithm is designed to input exactly 100 numbers. However, we can see in this line that until count is greater than 100. This is wrong. The correction should be until count is equal to 100. Example 2. Here, we are required to spot 4 errors. Let's first read the algorithm. This algorithm is used to input 10 numbers, check whether each number is within a specified range, and totals the number within the range and outside the range. Let's see. In range is equal to 0, out range is equal to 1000, for count is equal to 1 to 10. Input num. If num is greater than 10 and num is less than 20, then in range is equal to in range plus 1. Else out range is equal to out range minus 1. Count is equal to count plus 1, and next x, then print in range and out range. So the variables in this algorithm are in range and out range. Line 5 is where the in range is counted, and line 6 is where the out range is counted. The first mistake I can see is that out range is equal to 1000, which is line 2. If the out range is 1000 and it is subtracted by 1 every time a number is outside the range, then the results will be inaccurate. The correction should be out range is equal to 0. The next error is line 6. The out range should be out range plus 1 since we are counting how many numbers are outside the range. Line 7 is also not needed. If count is equal to count plus 1 and next is present, Then the count is added by 2 every time the loop is repeated. For this, we can just write line is not necessary or line should be removed. Also, line 8 is an error since we are counting using the variable count and not x. The correction should be next count. Exercise question 1. Read the algorithm and find the 4 errors. Your answer should be like this. Exercise question 2. Read the question and algorithm carefully. This one is a bit tricky. Your answer should be similar to this. By the end of this video, you should know how to use the arrow operator and other operators, basic conditional statements in pseudocode, pseudocode for loop structures, pseudocode for standard actions, writing pseudocode for a given algorithm, and error checking pseudocodes and identifying common errors. Alright, one of the hardest chapters of the syllabus is finally complete. The resources used in the making of this video is shown to the right. Anyways, I hope that this video has helped you understand algorithms and pseudocodes better, and I'll see you guys in the next chapter, which will be an introduction to programming. I hope that it wasn't as difficult as you expected it to be, and please don't end up like this dog over here.